Good morning, sir. Can we start now, or do we have?
Yes, sir. We'll start in couple of minutes.
Sure, ma'am.
Participants are joining. That's why we are waiting for some more minutes. We will
Sure, not
start.
a problem.
A very good morning to all of you. On behalf of A.G. Patil Institute of Technology, I welcome you all on the fourth day of induction program on IoT. Today, for the first session, we are having an industrial expert with us. I welcome resource person Mr. Nitin Katke. Before starting the session, I would like to introduce Mr. Katke, sir. Mr. Nitin Katke is a founder and director of Synergy Engineering Services. He is a co-founder of IndustryRider.com, which is a B2B e-commerce platform for industrial supplies. He is MTech in Mechanical from IIT Delhi and did MBA in General Management from National University of Singapore. He has 13 years of rich and diversified experience across automotive, oil and gas, home appliances domains. He owned 3 patents and 6 international publications on electromechanical subsystems. He had worked with Halliburton, Cummins, and Whirlpool companies. He headed team size of 40 plus engineers as assistant general manager at Finite Four Technologies, a leading engineering services firm in Pune. He is certified as component communicator and competent leader by Toastmasters International. So, sir, I welcome you again and we are glad to have you today. Now, I request Mr. Katke, sir, to engage the session. Over to you, sir.
Thank you so much, ma'am, for the wonderful introduction.
Thank you, sir.
And thank you, everyone, for giving me this opportunity to speak on this elite forum. I'll start my presentation with the slide deck. Having some issue in presenting, give me a second. Can you see my screen now?
Yes, sir. It is visible.
Uh, okay. Um, Thank you again, and apologies for the technical snag. Yeah. So hope everyone knows who this person is. This is Nicola Tesla, and way back in 1926, he had this vision of connecting all the things on the earth and make the earth as a massive one single brain. In 1926, he quoted, "When wireless is perfectly applied to the whole earth, it can be converted into a huge brain, which in fact it is, all things being particles of real and rhythmic whole." So we are heading towards that reality, and that's within 100 years span. What a visionary he was. And then that is where I see was the start of the IoT. Later on, internet and other technologies followed, and today we see that things are talking to each other, and then we call it as Internet of Things. So today I'm going to talk about the importance of IoT in Industry 4.0. Of course, there are a couple of terms here which I'll be referring to again and again. Internet of Things, like the Internet and the things, and then Industry 4.0, and then how we have evolved from Industry 1, 2, 3, and where we are now, and what is the future next. So these are a couple of things, and I'll be keeping it introductory, or rather not going too much into the mathematics or into the details of things, but highlighting clearly and clearly the significance or the role of IoT in Industry 4.0. Rajni ma'am has already given this introduction, which I had shared. A few things I would like to highlight here. Again, my working experience with Cummins, Whirlpool, and Halliburton, and also with Finite Four, has given me a good amount of knowledge and the technical leverage to understand both technical as well as the management aspects of leading and introducing techno commercial projects. So I had the exposure of doing tons of projects while working with these organizations, and my 2019 MBA with National University of Singapore also has given me depth of understanding, applying those technical understandings and creating business models out of it. And currently I'm running two firms, that is Synergy and industryrider.com. So at Synergy, I'm clearly able to apply the concepts in management, to do management consulting, as well as we do a lot of engineering projects also. I'll take you through some of that work at later stages, and as and when things are relevant to the topic of discussion, I'll showcase some of the work that we have done, or particularly to IoT, whatever work I was involved in, and also highlighting some parts of industryrider.com, and how we are relevant for Industry 4.0, and how are we heading towards creating a smart factory, and a lot about that as we head towards the next couple of slides. These are some of the technical areas that I have worked in. While I was with Halliburton, I got the opportunity to work on mechanical systems and subsystems, and then I was involved in developing the mobile multi-sac apparatus. This is again a device which is an eco-friendly device, which is used for collecting the dust, airborne dust, and then storing that airborne dust, and then minimizing the environmental losses caused because of these dust. And then we got a patent for this. Also, I was involved in design of a downhole hybrid motor. So basically what happens in this is, whenever you're drilling downhole, you cannot just drill it straight, so you have to drill it at various bend angles to reach up to the reservoirs. So this was a small piece of work in that area, and most of my technical work has been towards design of mechanical, electromechanical systems and subsystems, and I have some technical publications listed on One Petro and SP portals. If you can just Google out there One Petro and mining, you will be able to find out these details. A brief about Synergy and what we do exactly at Synergy. So basically, the idea of Synergy is an aggregator platform for engineering services and or all other allied services. So right now we have started with CAD modeling as well as mechanical system analysis, and also we are into management consulting, IT services, and some part of it in the associated trainings. And then it's more like a diversified organization from the start itself, and we have office in Swargate, and we have like a couple of people working in different areas. And then it's like you can see more details about us on synergy-sq.com. That SQ in the URL stands for service quality, which I think is one of the important factors when you're dealing in the service industry. A brief about the Industry Rider platform. Industry Rider is basically a B2B e-commerce portal, and we are catering to the different industry needs, the supply needs of the industry. Particularly in times like everything is headed towards e-commerce, and people want deliveries to their pin codes. They don't want to do more search and all. So that is what makes us relevant. So we have started this some 6 months back, and now we are already shipping to 24,000 pin codes, and we have like 10,000 plus products already listed on our website, and we have 100 plus suppliers. And then we have a good backend team, particularly on the IT side. And then this is again two other IIT Delhi friends of mine, plus me, a 3 IITN company. And then we are now looking forward to develop strong industry relationships where we can become the preferred sourcing partners of different OEMs and the industry. So as of now, we have 100 plus customers, and then we are going strong on this. You can find more details about us on industryrider.com. So as you can see, we are catering to like various sectors, different industry domains, from construction, medical, whatever industry supplies you need, you can find it on us. So basically, this is a kind of a mini Flipkart kind of model, and the most important thing is creating value for the customers through ensuring proper deliveries. I'll refer to Industry Rider again when we come to the smart factory. There I'll tell you how we are making some change and how we are leveraging on the IoT platforms. Of course, you might have done a lot of introductory sessions on Internet of Things, but let me take you through a couple of points here so that we can build some ground to make some points in the couple of slides, upcoming slides. As you can see, Internet of Things is basically the internet and the things. So the internet is, you call it as 4G, 5G, or that day actually we were talking about with Mr. Anand Nayyar sir. He was talking about the LoRa platform. I had the opportunity to attend his session, and then I could also connect with him on LinkedIn, and we are already talking business and how we can take things forward. Yeah, so basically here you can see some of the sensors, particularly the temperature sensors, the different image sensing, pressure sensing, and proximity sensing. All of these sensing and the data that is generated because of this sensing enables us to perform the required task, that is executing this data and getting some insights which we can take decisions on. So basically IoT is it starts from this. These are the things, these are embedded in the things, and then the things start giving the data, and that's how we go about it. So how IoT works, I'll not go into much details of this, but I'll just touch base on the components here. That is typically we have IoT sensors, the sensing parameters that we had discussed earlier. So the sensors which can sense that, and then we have wireless connectors, and then the enablers include LoRa or Zigbee, Bluetooth, right? And then IoT gateway and the carriers like LTE or Wi-Fi, right? And then all these data is passed on to the servers where we can use this data. So basically, a lot of data, handling that data and then taking decisions based on that data. That is the most important part of it. IoT actually, in general terms, is bifurcated into two parts. That is industrial IoT and consumer IoT. Industrial IoT is anything that deals with heavy machinery, transportation, the smart cities, automation, you name it, like whatever is there on the shop floor, plus as well as whatever can be commercialized. The particularly on the heavier part, the industrial part, that is the industrial IoT, and then the consumer IoT, which people use on day-to-day basis, be it wearables or the appliances. And like we have so many things coming each day, including the doorknobs these days. They are connected to the internet. Gartner hype cycle is one of the popular concepts, and I'm sure everyone working on innovation concepts knows about this. Basically, Gartner hype cycle tells us more about how the technologies are evolving over a period of time. So they publish these hype cycles every year, and then based on that, how the technologies are evolving. So here you can see Internet of Things, and this hype cycle dates back to 2012, some 9 years ago. And then Internet of Things, you can see orange triangle here. The orange triangle represents like it's more than the technology will take more than 10 years to reach the plateau. So basically, this is a typical innovation cycle in which when the technology is new, it will have a technology trigger, and then it will go up to a peak where there will be very high expectations out of that technology, and then it will start dropping down, and it will stabilize somewhere, and that is what we call it as the plateau of productivity. So in 2012, Internet of Things was somewhere like it was projected to be on the plateau of plateau of productivity in say 20 or 22. So we'll see how it has evolved over years. So fast forwarding 3 years, in 2015, it was already on the peak of expectation. So in 2015, it was like one of the most talked about emerging technology. And then everything is going to change, and of course it is changing now. But that is the way it has been traversing along this hype cycle. And then in 2018, it has started moving forward on the curve. Of course, I don't have the current 2021 curve with me, but then even in this 2018, it shows it was around. It will take around 5 years. That means around 2023. It will be on the plateau of productivity. So we can see almost like it's applied in the industry. IoT as a technology, as a platform, is applied to so many things. It has already started delivering the productivity results and outcomes. So of course we'll see some of the numbers in the upcoming slides. So I believe it is somewhere now on the slope of enlightenment, and we will have IoT as a stable tech in coming years. Um, the other part of that is industrial revolutions. How have we arrived at Industry 4.0? So starting with just a second. Okay, starting with Industry 1.0. It was like James Watt who developed this steam engine, and then that was the start of the industrial revolution 1.0. And as we all know, that is where the industry started to flourish, and we developed so many so much of industries after that. And as things evolved, we started like the electricity was evolved, and then electrical machines, and then we started getting into area of mass production. That is where we are calling it as Industry 2.0, where things were churning out faster compared to the earlier version. So it was a period of automotive and the cars and other industries that were fast booming. Later on, as we moved forward in particularly in electronic segment, the transistors, the computers, and everything started evolving, and that led to Industry 3.0. Actually, it is these are just concepts, or it can be called as we are viewing something in as a retrospective concept. But there's nothing like a fixed timeline when 3.0 started and when 2.0 started. But then after all, we can call it as these are the trigger points. Say, like, we can call evolving of ML, AI, IoT as somewhere Industry 4.0. So in Industry 4.0, we see a lot of current technologies, big data, IoT, and then blockchain, and a lot of work is happening on this day-to-day basis. So today, if you say that I have a problem, and then I have a tech issue, maybe somewhere around the world, someone is already working on that tech issue, and that is being solved much faster than than you anticipate. And that is Industry 4.0. That is where things are evolving much faster than what our anticipation is. Of course, there is some speculation for Industry 5.0, and we live in an era where we have different versions of the iOS and the Android. So the Industry 5.0, 6.0, that will keep on coming. But then there are some set expectations of Industry 5.0, and maybe we'll have a glimpse of that in the coming slides. So basically, Industry 4.0, if I have to summarize it, it is like two things: the intelligence and information. Intelligence is artificial intelligence, we can call, and information, big data, IoT, and cloud. So once when these things are clubbing together, it's giving us insight on how we can take and evolve based on this decision, how we can make decisions based on these data. And this confluence and convergence of different technologies together is causing this fourth industrial revolution, as we call it, as Industry 4.0. So we have IoT as one part, and we have Industry 4.0 as other part. So what comes in between is like Internet of Things when it is applied to. Hello?
Sir,
Yes, ma'am.
so, sorry to interrupt. Can you make your presentation in a slideshow?
Yeah,
Because
yeah.
the content on the PPT are not visible.
Okay, okay, sure, ma'am. No problem.
Thank you, sir.
Is it visible now?
Yes, sir.
Okay. Yeah. So on the IoT side, when we call it as consumer IoT or even the healthcare, mobility, a lot of things are happening on that front. But here, the focus that we are going to discuss is on how IoT is enabling Industry 4.0, and then a bit of touch on how the smart factories, what's happening at the smart factory level, how the connected devices and the smart grid, heavy machinery, how we can leverage this tech, particularly IoT, and how it has started. What is the significance of this in Industry 4.0? So basically, if we have to name a few techs which are disrupting the factors in the different aspects of Industry 4.0, IoT would be one of the topmost factors out of it. And then that's why we can also call it as a backbone of Industry 4.0. So we cannot really imagine Industry 4.0 without IoT and say cloud, for example. So that forms the basis, or that's helping other techs evolve. So a touch on smart factory. So basically, smart factories, again, a concept which I would call it as a subset of Industry 4.0. So where we can envision a factory which is loaded with tech, you name it, artificial intelligence, augmented reality, IoT, and internet and virtualization, cloud. So enabling this factory work autonomously on its own with as little manual intervention as possible. And then the factory itself is able to do a lot of things on its own. And then the manufacturing is smarter. The products that are coming out, or the input, the raw material that is going into manufacturing of these, the machines that are processing the raw material or the data, they are smart enough to deal autonomously in a smart factory. So on a concept level, it's basically a great working together of, I mean, it's a great confluence of all the tech in one place. That's what we'll call it as a smart factory. So basically, you have a lot of intelligent aspects attached to it. Say, for example, the dashboard, which is giving us the information about what's happening on the shop floor. That's kind of automated, or that's going to give us some smart information. Right, and then we are going to leverage on the data, and based on that data, it's going to be a automatically reactive system. So that is a smart factory. How Industry Rider is coming into this space is basically, Industry Rider has started working with different OEMs. Um, uh, Basically, we are into the e-procurement domain. So whereas when these OEMs or our clients, when they need different industrial supplies, so they have their own ways and means of quantifying the supplies. So basically, you have, say, for example, one company has got different plants, or and then they have different vendors for these different plants. So what happens is they'll have to interact with different people for they'll have to interact with different people in order to get their work done or to procure material. So that's causing them a lot of inconvenience, or in terms of maintaining records, or it's even time consuming. So basically, we are coming into a place and trying to solve this problem, where we can have automated ERP systems working directly with them, and then enabling that quicker delivery of those industrial supplies. So it's going to be less time consuming, and then Also, when you're dealing with so many vendors at the same time, there are too many interactions, too many email communications. Sometimes you don't have a product, and then you don't have a material, and then there is a lot of downtime because of that. And with smart factories coming up, or the decisions are taken based on the data, or in this case in particular, when the decisions are taken based on the availability of the current inventory, industry rider is developing that tech to give to give that raw materials to the customers in time, and even before they know that they need that materials. So how we do that is basically we are talking with their inventory levels, or basically a system in which they have basically creating a system in which their inventory and whatever is the plan ahead, what is their forecast of the materials that is required. So we are keeping the material ready for them for the future. So that's how we are trying to be part of the smart factory. So, as I said, there are different pillars of Industry 4.0, and IoT is one of them. The other pillars include big data, cloud computing, or 3D printing. Cyber security is again one of the key ingredients when you talk about internet, mobile tech, RFID. So, all these pillars are supporting this big concept of Industry 4.0. And then the confluence of these together is making this Industry 4.0 possible. And then this revolution, as we call it, is possible just with all these tech. Say, for example, we have the data that is generated by the IoT devices. There is a lot of such data, and we have to take a decision based on that. The big data and analytics techniques can be used, and then all these together can really form emerge as revolutionary concepts. So you see, day in, day out, things are moving pretty faster. Yesterday, I was watching at Sundar Pichai, and then he was talking about how things are evolving. So Google is developing a tech now where they can read the conditions of a heart, a human heart, based on the reading the human retina. So that imagery captures the changes in the changes in the veins, or the blood distribution, or aging of the retina, and how that data can be and such data is studied for different people, and their medical conditions are studied, and then mapping this to gives us insights of that person particular could have certain heart ailment. So all of these is possible only with the confluence of all these things coming together. So that way, if there's one tech that is standing apart, we will not be able to leverage much on that. But when these technologies are coming together, that's all going to create the revolution. So IoT Analytics is one of the good websites which keeps on reporting different techs and how they are evolving. So when you see their tech report of 2020, it lists IoT. Of course, these numbers are not sequential. So it lists different technologies which are disrupting Industry 4.0. And particularly, you can see all these techs which we were talking about. Artificial intelligence, AR, VR is there, then the digital twins, cobots, where robots and humans can start working together, and then IoT. So if you see in all these techs, out of these 17 techs, I would say more than half would have not been possible without the rise of IoT. So that is how IoT has got a significance in Industry 4.0. It is enabling other technologies to evolve as time goes by. if we see industry-wise, which are the technologies which are adopting Industry 4.0 most? So as you can see here, the indicators clearly tell automotive is one of the leading industry where Industry 4.0 is 36%, as is the case here, followed quickly by computers and electronics and electrical equipments, and also by like metals and mining. So Industry 4.0 is rapidly catching up with different industries, and IoT is definitely a big part of these changes and these revolutions that is happening to industries. So IoT is at the heart of Industry 4.0. Here, what I have shown is a typical manufacturing plant, or let's call it as a smart factory, and how things are happening at the factory level, and how things are transforming at and how all the stakeholders involved are changing or making decisions based on that. On the shop floor, you can monitor the production flow. You can monitor the production flow in real time, and when you're talking about the machinery, you can manage the equipment remotely. You can sense the temperatures, and if give me a second, actually. Just be back. And then how things are evolving on the supply chain side. So with IoT enabled devices, even the global management, which is sitting across oceans, can make decisions for the events that are happening on the shop floor. So year on year, you can see how so many devices are being added to IoT tech, and then that's boosting Industry 4.0. Starting with 1992, with starting with 1992, and then how with the advent of computers and internet, how things have started to evolve. And then the concept of IoT was conceptualized. I mean, it started evolving in 2009, and then now you can see the different wearables and all. They've started evolving, and now it started with a couple of hundreds and thousands, and now it is like 50 billions of such devices, including your doorknob, toothbrushes, are all connected to IoT, and all of that is influencing the Industry 4.0. So this gives us a glimpse of how the market of Industry 4.0 is evolving over a period of time. So here you can see that the CAGR, it is growing at a CAGR of 16.9, which is pretty much impressive. So basically what it means is year on year, there has been a significant growth, and most of that is happening in, say, North America or APAC, which is mostly China. And then this industry is evolving, and now like it's evolving continuously on year basis. Here you can see the particular components of which industries or which industries are particularly having more CAGR growth for IoT endpoint electronics. So mostly you can see manufacturing and natural resources, they're evolving faster, which means it is directly contributing to Industry 4.0. So the other industries which have been influenced include the consumer automotive or the commercial automotive transportation, which again is directly giving a boost to Industry 4.0. So mostly this slide tells us mostly about the investments that are happening in the IoT sector. So the manufacturing sector is predominant with as you can see over the years from starting with 2014-15, there has been a growth year on year in these investments, as well as there has been a growth on the industries as well. I mean, say manufacturing, transportation, or you name it, and then it is growing year on year. So that clearly shows us how the significance of IoT is increasing in the industries, and it also tells us how it is also helping in developing Industry 4.0. Applying these certain learnings to India, India specific, if you see, the robotics or the robots that are used, see, compared to South Korea or the US, you can see only 3 robots are used per 10,000 workers. Of course, the conditions of India are different from South Korea or the US, but it also means that it is a clear indicator that India as a nation is a bit of lagging in application of IoT compared to the other advanced nation. I would rather see it as an opportunity for the budding entrepreneurs because it gives us a little bit of room to bring the new tech to our country. This is a typical value chain for IoT businesses. We had learned earlier how IoT works, and then there are sensors, and then there's connectivity and how the data is used. So there are some brand names in these areas, say particularly when you're talking about, say, smart objects. Fitbit, for example, it is developing these devices, handheld devices, wearables rather. um, uh, and then on connectivity side, AT&T and others who are again working on 5G. And on the platform side, Google, Microsoft, they're doing pretty well on it. So coming to the different applications of IoT in Industry 4.0, the different applications involve robotics or maybe industrial applications, the shop floor or the logistics, smart cities, automotive, of course, is a big thing, and then home appliances, even the mobile communications and all. You name it, and then that industry is touched with IoT. What are the major factors which are driving the demand for IoT implementation? So the top 3 factors that I would call are getting a competitive edge over the competition. So having a tech which is not there with the competitors gives us the competitive advantage, and leveraging on that tech, we can create bigger markets and beat the competition. Same way, increasing revenue by reducing the system inefficiencies or getting understanding from the data and what changes needs to be done. And then saving cost is again one of the factor which is pushing the industry for implementation of IoT. How IoT has been affecting or helping the manufacturers? Of course, it has been helping by giving the best of product quality, and then tracking the defects, and with that information, how we can continuously keep on improving. And then maybe with another tech like AI and all, continuously developing better and better products day in, day out. And then real time supply chain management. So it is also helping them track what's happening where the raw material is and where their sourced material is. So that tracking is continuously happening, and that is very much possible in Industry 4.0. And then faster and cheaper product prototyping is also the talk of the town. Advantages of Industry 4.0. Um, Industry 4.0 started somewhere in Germany, some 2009, and then it started to evolve. And then Europe quickly adopted to it before anyone else. So as a result, um, the European companies, European industries, they started benefiting out of it compared to anyone else. And then if you see overall, like 50% of enterprises that have Industry 4.0 tech have almost doubled their growth in 5 years time, which clearly highlights the significance of this IoT in Industry 4.0. IoT has enabled or has helped increase in the efficiency and hence better productivity. See, like different MNCs, including Cisco, Siemens, Airbus, GE, they are continuously evolving and using this tech to increase their efficiencies day in, day out. So increase in these efficiencies or reduction in the downtimes, or that's helping these businesses grow faster, and that's also helping developing the ecosystem, IoT ecosystem, much faster. When it comes to the traditional conventional way of doing things and an IoT enabled ecosystem, you can see that in a conventional way of doing system, when you have a machine downtime, it takes like much more time to recuperate out of these downtimes and then get back to the normal manufacturing. Whereas when you're using the tech like IoT, it helps based on the data, it helps recover faster. And then you can see here companies like Boeing and GE, they are the pioneers and using these technologies to reduce the machine downtime. As per a Deloitte report, which states that the predictive maintenance, so we can preempt which machine is going to have a breakdown based on the data that is captured, that is captured. So based on that data, we can predict which machine is likely to fail, and then doing predictive maintenance before that breakdown itself leads us to lesser downtime. Better matching of supply and demand. So on the supply side, you have, say, like different suppliers who are providing you with the raw material and all. Now you know what inventory is with you and what inventory will be required for for your upcoming say productions. So with IoT in place, this gap in the supply and demand, whereas sometimes there is too much of inventory in stock, or sometimes there is a total scarcity. So these gap in the supply and demand is very well met with the help of IoT tech in place. So how IoT helps shop floor directly is when you're talking about shop floor, and IoT has been transforming these shop floors literally with the current conventional ways of doing things, particularly when the labor and then the man-machine management. There is a lot of reduction in the labor and machine cost. Of course, there is initial capital expenditure required to execute these techs, but then over a period of time, this capex is very quickly recovered, and then The IoT on shop floor enables for accurate data from these say man or machine. So we can get continuous data, and we can process these data to arrive at better decisions. You can also increase the operator productivity and efficiency based on the data captured. Overall operational effectiveness can be very well enhanced using IoT. Say when you're talking about the resource consumption, for example, energy, you can very well have the data for which appliances or which equipment on the shop floor are using more energy, and why is that so. So doing that analysis becomes very easy with the help of IoT, and then that leads us to, of course, better efficiencies and better effectiveness. Likewise, the digital twins or cobots, edge computings, all of these are helping in improving the operational effectiveness. So as I was talking about the inventory management system, so there are a lot of tools available, cloud-based tools available for inventory management. For inventory management, so demand and supply can be very well can go hand in hand, or if not hand in hand, like there is a little variation between the demand and supply. Once we have the data, and then the forecast can be made better with the help of these cloud-based systems. Um, it can also provide us real-time insights and give us greater business agility, and improve products and design quality and controls. So basically, that is how IoT implementation of IoT in industry can be useful. Location tracking can offer surprising cost savings. I was working on a consulting project with a firm. So what they are doing is they have attached tracking devices to the workers, and then if they are going in the restricted areas, that is monitored on a day-to-day basis, and then such movements are unwanted for, and then based on that data, the efficiency of the people can be improved. So that is how the location tracking is helping many people. IoT as an enabler. When we say IoT as an enabler, there are different other things that are made possible because of the rise in IoT as a tech. Say particularly identification of opportunities. Once you have so much of data in hand, the management can make decisions to enter into certain areas and exit out of certain areas. So that is IoT as a tech is helping them identify new opportunities for businesses. Optimizing supply chains and logistics, from the supplier up to the end consumer. The logistics, the movement that is happening of the goods as well as raw materials, whatever that movement is happening, that can be very well optimized. So based on the data, in fact, I have a consulting project which I'm going to discuss more about. So I'll come back to the details of these slides in while discussing that. So basically, overall optimization of each and every parameter. Where are the lags, or why are the delays happening? So that can be traced easily, and then continuous learning can happen based on that. Introducing of robots and cobots is very much possible because of IoT. Now, say cobots, it's helping do the continuous and monotonous tasks on a day-to-day basis. So these tasks can be done, like these robots can be done to execute these tasks, and then IoT can help us do that. Self-assessing vehicles and equipments with IoT and the data that is generated. Um, the vehicles and with, of course, AI coming into picture, uh, uh, continuously the vehicles or the equipments which are working, say, on the shop floor or in factories, they can keep on like assessing themselves or evaluating themselves, how they're performing, and then um, based on that, again, that helps us in decision making. 3D printing is one of the leading technologies today, and that is, I would say, like the implementation of 3D printing has been, IoT has been a key backbone in implementing of 3D printing. Nowadays, we are talking about designing something in office in India and then manufacturing it somewhere in China, and then that can be done with 3D printing. So you just have to design something, and then with a 3D printer placed in China, you can do the 3D printing, and all of these can be is enabled because of IoT, and that is where 4.0 is, Industry 4.0 is. Despite so many advantages and tech, there is still a lot of resistance to implementation of IoT. And the top parameters include, like, lack of budget, for example, as I was talking about the initial capital expenditure on these techs. So that's initially cost, but that cost can be recovered much earlier than anticipated. And then incompatibility with the current systems. And then at times there could be uncertainty on the return of investments. And say, for example, in country like India, it's again, it could be because of the resistance from the current workforce also, because more and more implementation of IoT and say robotics on the shop floor could lessen, I mean, the jobs, and also because of that, there is some significant resistance to implementation of IoT. Apart from that, there are some technical challenges, of course, including mostly the security vulnerabilities. What if someone hacks into your system? Because you're talking about the internet, and then internet is again susceptible to hackers. So these hackers can get into your systems, and then it can cause major damages compared to current breakdowns. So these damages cost could be significant. So and apart from that, there could be some cost constraints, and then expertise. Do you really have that level of people who can execute the IoT projects for you? So these are some of the challenges in implementing IoT. Of course, these challenges of today are like easily overcome tomorrow by a new tech, or as things evolve. So some of the leading just some of the leading industry 4.0 vendors, they include I mean, if you segregate it in different terms, um, say in additive manufacturing or in augmented and virtual reality, there are some key players. So currently focusing on the industrial IoT platform, Google, GE, IBM, Cisco, even Philips or Bosch, they're doing a lot of work on developing this platform and implementation of these platforms. These are some of the startups that are continuously transforming the shop floors, the oil fields, and the supply chains. So I've segregated them based on the areas where they are making the transformation happen. Say, for example, in connectivity, Sigfox or Actility that day we were discussing about, they are working so much on connectivity. Machine to machine or satellites, Kepler is working in that domain. I have a close working relationship with Gray Orange. So Gray Orange is basically they have robots which are used for stacking material as it arrives on the floor. So basically what happens is there are some hundreds of robots on which are carrying these pallets which are to be stacked on a shop floor. So these robots, they're talking to each other, and when they are moving on the floor, they're moving faster and they don't collide, of course. And then they have the designated places where they need to, where they can keep these, stack these pallets. And as they move from one place to another, the data is continuously helping identify where is what. And then this is a new age startup. And then similar kind of tech is also implemented in Alibaba. So I had the good fortune of seeing both these technologies. So eventually, things are going to head in these directions. Things are going to be like automated, and it's all possible because of IoT. And there are a lot of industrial AR, VR startups. So if you look at websites like Crunchbase, so there you will find more and more startups coming, and then the funding that is happening to these startups. So nowadays, if you see, if you just track some business websites and all, a lot of unicorns are happening, and then new techs are coming, and then people are leveraging on these technologies and creating a solution to a problem. And IoT is a great enabler again in these techs. Other areas where these startups are again booming: universal platform and edge intelligence. So there could be some names like Clearblade, that is what I've heard of. And then particularly vertical specific, that means industry specific. A lot of work is happening in say oil and gas also. At the same time, agriculture and how things are evolving in this field, say smart grid or warehouse. So warehouse, again, green or gray orange is doing a lot of work on these warehouse tech. Advanced analytics, be it like cybersecurity, AI, ML, a lot of startups are booming in these areas, and they are continuously transforming the factory floor. I will touch base upon a few consulting projects that I was involved in. This is a real-time smart parking system. Though not exactly a part of Industry 4.0, but then it has a good involvement of IoT, and then IoT as I mean, as a consumer IoT, we can call it. So basically, the problem that we were trying to solve here is there are a lot of parking spaces around, particularly when you talk about the airport or the malls. But and they have multi-storied parkings, and then when you go there at times at peak hours, you don't really find a parking. So you need a solution to that. And then the way we are working on it is we designed sensors which can sense the open parking slot, and once the data is available, the data is passed on to to the server, and then that data is again accessible in the form of apps. So that way, whenever someone is entering a mall, and if he is able to see, like, the parking slot is available on, say, third floor in these areas, you take a left, you take a right, and it will navigate you there. So that is the kind of work I was involved in. And then this was a mini tech that we had developed. Likewise, I was involved in consulting work for a firm for IoT and cloud storage, sorry, cold storage. So what happens in cold storage is one of the most important factor is when you're taking the foods and medicine, the time is very crucial. So with that shorter duration of time, you have to reach from one place to the other. Otherwise, the food or the medicines, they'll get damaged. So from the manufacturer, once it is moving, say, in a cargo, and then it is going through ships or through trains, that continuous tracking is required. Now, in this image, what you can see is a single source of manufacturer. But just imagine if there are hundreds and thousands of such manufacturers, and then hundreds and thousands of such trucks which are continuously taking the medicines or the food, and then it needs to be delivered across oceans to different places. Then it really makes the situation more complex, and then you need a lot of IoT and other techs to solve this problem. um, so basically, continuous understanding of the issue, and then arriving at the bottlenecks, what exactly is causing the delays, and then continuous improvements based on that. That is what helped us arrive at better results in this particular project. So of course, we talked about Industry 4.0. So what's next? Of course, Industry 5.0, that version thing keeps on going. So what we really would see in Industry 5.0 is basically, as the literature is available, people are speculating. It's more about a speculation, because there is nothing predefined thing that from here on we'll call it as Industry 5.0. But the speculation is when we have Industry 3.0 and 4.0 merging together, whereas we are calling it as mass customization of things, and which is having a personal human touch. So for example, if I want to manufacture, say, glasses, so these glasses can be mass manufactured with, say, everybody's name on it, the personal touch to it. So that is where 5.0, we will be calling it as a start of 5.0. Likewise, enabling technologies which could have interaction, say, via voice or even the brain waves, say, transmitting something, whatever I'm thinking, maybe directly transmitted to the machine. But of course, that looks a bit away from now. But then what we have learned from the earlier industrial revolutions is things come pretty much faster than we anticipate. This is actually, as Synergy, we do a lot of consulting projects in both tech side as well as management consulting side. So here I have tried to represent one such idea. I mean, if you have an idea, we can really convert that idea or product. I mean, there's a lot of work that can be done from product to market. So here, this is a blue ocean strategy. This is just a glimpse of the different management consulting works that I do. So this is, say, for example, green line is a product 1, and the blue one is a product 2. So, and you are developing, you're wanting to develop a new product. So as they call it these days, or it has been always, innovation is not just limited to tech, but how you implement that tech and how you monetize that tech. Because the second part is equally important. Say, for example, Elon Musk was recently asked about Einstein, about Edison and Tesla, who would you prefer if you had a choice to make? He said, I would want to become Edison. Though the name of his company is Tesla, he said, I don't want to become a Tesla. That's obvious because he said, though Tesla had better invention capabilities and he has done a lot more work than Edison, but Edison was the one who could bring the technology to the markets. So the second part is equally important, bringing that technology and making it reach to the people. So we do some kind of consulting work in that area also. So here, the point that I want to make is, say if you're developing a new tech and then it has got different parameters or different factors on which that product will be measured, say connectivity, sensing, or range, or the software, the cost, or the manual intervention required. So you have product one, say in the blue line, green line, and the product two in blue line. And then say, for example, cost-wise, this greener is higher, whereas the blue one is cost-wise, it is lower. However, it is having certain other advantages. And you want to develop a new age, new product. So you have to, first of all, arrive at the different factors on which it will be measured. And then here, as you can see, some factors you're raising the bar. Say, for example, the software or the UI interface, you're raising that bar. Whereas in compared to both the competing products in the market, and whereas in certain areas, say cost, you're reducing the costs. And say, for example, in manual intervention, suppose if these two products, they need some kind of manual intervention, you can totally eliminate that. Whereas you can add something which is not there totally in both the products. This is what you're creating. So this is what we call it as a blue ocean strategy. Basically, what it means is you're creating a blue ocean, which is different from a red ocean. Red ocean is all bloodbath and where there is too much of competition. So this is a blue ocean where there is very less of competition, and developing products and tech in that area where there will be a minimum of competition, and how we can really break down the requirements of that product and then create a totally new market for yourself. So if you have an idea or a product in these space, IoT or otherwise anything, I would be happy to help on these fronts also. So there are different business models, pay-per-use or subscription basis or data-driven. And this is a typical business model canvas where we can understand what is exactly the problem and what problem you're trying to solve in the process, what is the value that we are creating for the client, and what could be the revenue models. Say, I can have it on a subscription basis or a pay-per-use basis, but then depending on the current what model should be, doing a kind of a mini simulation of that kind will help us develop that product into a better company. So apart from that, if you have anything, I would be happy to help. My details are provided here for engineering projects and consulting. I can be reached out on this mail ID, and then this is the website URL. For procurement and industrial supplies, I can be reached out on this mail ID. And of course, I would be happy if you can visit and have a look at what things we are building at Industry Rider and Synergy. That will definitely give a lot of motivation. That's all what I have now, and then I'm open for taking up questions. Hello? Hello? Hello, am I audible?
Yes, sir, you are audible.
Yeah. I said like I can take up some questions if you have.
Participants having any doubt, kindly ask them in a chat box, or you can unmute yourself.
I have also shared the presentation with the recursor, and then sir can also share it with you in case if you find something interesting and would like to be in touch. I would be again happy to help on that front also. Yeah. So, a few threats and challenges in this particular domain, as I was talking. Most important, I will take you to the slides. Um, Most importantly, since it is internet driven, so people think of it as it is having see IoT is a lot of exposure to internet based hacking or uh, the data, particularly when you're talking about machine data or the human data that's continuously being monitored. The data that is stealing of that data or misusing that data, that is one of the key things which is which is causing people to restrict themselves from implementing these tech. I was told to share some questions also with you, so I don't know how do I do it. Um, Um, uh, for startups, what aspects of IoT one should be aware of? See, actually, it depends on what kind of startup that you would want to be in. Because after all, a startup is something that a problem that you're going to solve. So if you have that problem in mind, and you know of someone who is already working in that domain, the best ways to connect and understand how you can really solve that problem. But if it is like as per your question, if it is a IoT based startup, then again I would say it is two-faced. So suppose if you have uh, on the tech side, if you want to develop a new tech, so then of course, as I said in the blue ocean strategy, say in case what are the factors that you really want to improve. Of course, you may be having some competitive products in front of you, so what are the factors that you want to improve? Say for example, Dr. Nair was presenting that day, and then he said that connectivity can be improved up to 2.7 Mbps, as I remember correctly. He's trying to improve on the connectivity and also on the range. Depends again on what problem you're trying to solve. Um, Arvind sir is asking for the slide of 5.0, Industry 5.0. I'm resharing again. So basically, this is again some kind of speculation and then there is no hard and concrete material which will tell us how industry and how and when industry 5.0 will start. But um, when the human touch or the human I mean, when we'll be reintroducing this human touch to products, or more of customization driven mass production will start. That will be the start of industry 5.0. That is what is believed based on a couple of literature reviews that I have done. But then as such, there is no concrete evidence or concrete mention, because already we are in 4.0, and then that too, India is too far in 4.0 itself. So 5.0 is long way ahead. So any one of you is working on, it will be like, I would be happy to discuss and share, since we have a couple of minutes, is working on like IoT products, projects, startups, working with startups. Like, I would be happy to help or collaborate on that front.
Yes, sir. We have some projects on IoT,
Yeah.
which is based on the cloud computing,
Okay.
and the platform is Azure and AWS.
Okay.
Yeah, and we have to connectivity and interface with the some nodes are there, which is considered for the sensor node is there, and we have to compute with the cloud, and we have to manage that data set through the mobile and through the laptop and computer. But
Okay. Okay.
all the AWS servers are remote based, which is availability zone and region wise.
Okay.
Yeah.
And what is the problem that we are trying to solve here?
The problem is nothing but the only for the interfacing with the node and the cloud interfacing is there,
Okay.
and mobile to the cloud. So
Okay.
we have to require the one third party software which is connecting with the cloud and our system, that is
Okay.
host system.
Okay. Okay.
And the rest of thing we have to gather the collection of data. It is in S3, as well as we have to deploy the server in a EC2 instance.
Okay. Okay. Okay.
Yeah.
Great.
But the major problem is interfacing with the cloud. That is the major part.
Right. Right.
Yeah. Thank you, sir.
Thank you so much, Amol sir.
Yeah.
Thank you very much, sir.
Thank you, ma'am.
It was really a very wonderful session. It was really informative. You have given clear view about what is Industry 4.0, how IoT is the heart of Industry 4.0, what is smart factory, and you also told about the 3D printing. It gives
Yeah.
us idea how IoT is going to be a buzzword in Industry 4.0
All
in
right.
coming days.
Right.
So on behalf of AJ Patil Institute of Technology, thank you for sharing your valuable time with us and knowledge with us. Thank
Thank
you
you so
very
much,
much.
ma'am. It was an honor to be here.
Thank you, sir.
Thank you, ma'am.
Now we will gather at 1 p.m. for next session. It will be conducted by yesterday's resource person, Dr. Damodar Reddy, sir. So I request all the participants to be present on time. Thank you. Thank you, Katke, sir.
Thank you so much, ma'am.
Thank you very much, sir.
Thank you. So may I exit the meeting now?
Yes, sir, sure.
Yes, sir. Thank you.